Welcome back. Now we'll look at equations with absolute value. So what is a typical equation like this? Well, we could write something like absolute value of f of x should be equal to some function g of x. The only thing we have to account for here is what does the absolute value do? Well, I know that the absolute value of f of x is equal to f of x when f of x is greater than or equal to 0, and negative f of x when f of x is less than 0. What this tells me is that to solve equations like this, I essentially need to consider two cases, one where it's positive, one where it's negative. So it suffices to solve 1, f of x equals g of x when f of x is non-negative, and 2, negative f of x equals g of x when f of x is negative. So this looks complicated. I need to, in general, consider two separate cases. On the CLEP, we will focus on the case when f is a linear function and g is constant. So something like the following. I have absolute value of ax plus b is equal to c. Based on what we just discussed, we know that this splits into two cases. The first is when ax plus b is greater than 0. And my equation just becomes ax plus b is less than 0. The second is when negative ax plus b when ax plus b is less than 0. In this case, the absolute value flips the sign on ax plus b, and I get negative ax plus b equals c. Another way of writing this, then, is simply ax plus b equals negative c. So in summary, in order to solve an equation like this, I need to solve two equations. I need ax plus b equal to c, or ax plus b equals negative c. So it's very typical for these types of problems to do each one separately. For example, let's say we had 2x plus 1 was supposed to be equal to 4. Based on what we just discussed, note there are two cases here. This splits into 2x plus 1 equals 4, but also 2x plus 1 equals negative 4. So I'll solve both of these separately to get two possible values of x here. Subtract 1 to get 3, so x is equal to 3 halves in this case. In the second case, I get 2x equals negative 5, so that x is equal to negative 5 halves. So in conclusion, there are two solutions to this equation, 3 halves and negative 5 halves. Let's do one more. Absolute value of 3x plus 4 equals negative 1. Now, we could go through the process to try to solve this, but something we would find is that it's not possible, because we know that this is always greater than or equal to 0. So in particular, for no value of x will it equal negative 1. So there are no solutions to this. So this is sort of a trick question to see if you understand how the absolute value works. So let's do one more question that actually may have a solution. We can look at 3x plus 4 equals positive 1. Absolute value can give you a value of 1, so this makes sense. So we split. 3x plus 4 equals 1. 3x plus 4 equals minus 1. So here I get 3x equals negative 3. So x equals negative 1. Here I get 3x equals negative 5. So x equals negative 5/3. So I conclude again that there are two solutions, minus 1 and minus 5/3. This is very typical to, again, have two solutions to an absolute value problem. So if you're doing this on the CLEP, you should expect to have two solutions.